2.6, 2.7, number 14. Again, you should have a similar expression, rational expression, and we're going to graph it, find x and y intercepts, vertical, horizontal asymptotes, or a slant. So let's start by finding these restrictions. And so I just write down, like, is there a vertical asymptote? And so we're going to do the x minus 2 is equal to 0. What makes the bottom 0? And then you say add 2 to both sides, in my case, and I get x equals 2. So I'm looking for the vertical asymptote at 2. However, if you start these problems by graphing it, do x squared minus 4, x minus 2 is my problem, and I graph it, it looks like, maybe I typed this in wrong, but the idea is if I would shrink this down to, let's say, 0 to 4, you can see that there's actually a small hole in the graph above the 2. So this looks like a linear, but if we go back here, if I take my top and I factor it into x minus 2 and x plus 2, and I have an x minus 2 on the bottom, essentially those two things would go away, and this graph behaves like y equals x plus 2. Now the original is like this. So what's happening here is at x equals 2, you would draw that line in, and you would put a hole above the 2. So let's figure out a little bit more detail. And horizontal asymptote, this is a second degree over a first degree. So that tells me that this is big over small, which means there's a slant asymptote. And so technically you should do your long division, which would be x squared minus 4 divided by x minus 2. And so you have to put an x on top. X times x is x squared. X times negative 2 is negative 2x. And you subtract. Those two will subtract to 0. Now remember, this is 0x. There's no x up there. So you say 0x minus negative 2x would be 0 plus 2. So I have 2x minus 4. And then I have to put a 2 up here. So 2 times x is 2x. 2 times negative 2 is negative 4. Because those are identical, I do get a remainder of 0. So my slant asymptote is at y equals x plus 2. Which is actually the same as what we're getting when we do our factoring. So when you go up 2, and now you have this slant asymptote cutting through there. All right, let's keep going. So if I was going to find I like to find the y-intercept next. Let's find the y-intercepts. That's when x is 0. What's your y value? So I'm going to kind of clean this up here. I'll just do that. If I put a 0 in for my x's, I'm left with negative 4 over negative 2. And negative 4 over negative 2 is 2. So, yep, we're hitting right there at 0, 2. And to find x-intercepts, what makes the top 0 but not the bottom? So what makes the top 0? So again, that would be x minus 2 and x plus 2. So I get x equals 2 and negative 2. So you might be thinking, oh, I have an intercept at 2, 0 and negative 2, 0. However, remember that 2 right up here, if you take that 2 right there and you look up here, it also makes the bottom 0. So I can't use that one. So this is not an x-intercept. Only the negative 2 is. So go to the left 2 and we're hitting right there. So when you look at the graph, it should make sense why it looks linear now. And you can see the slant asymptote is actually the graph. So let's answer these questions down here. What is my x-intercept? The only x-intercept is the negative 2, 0 for me. What is the y-intercept? 0, 2. The vertical asymptote, there is no vertical asymptote, DNE. It was not a vertical asymptote. We consider this a hole, right? So when I graphed it, I would have gone like this, and I would have put a hole in my graph. And then the horizontal asymptote, again, no horizontal asymptote. We came up with a slant, so that's DNE. And then where does that hole occur? Well, if you think about it, when x equals 2 would go here, it wants to be at 4, so the hole would be at 2, 4.